Okay, statistical treatment of random error. Individual results for a set of replicate measurements will seldom be identified. Individual results for a set of replicate measurements will seldom be identified, and it is thus necessary to select a central best value for the set. Individual results for a set of replicate measurements will seldom be identified. And it is thus necessary to select the central base value for the test set. The central value of the set must be more reliable than any of the individual results and variations. Among the results provide some measure of reliability of chosen best one. Hence, statistical methods are employed in interpreting the average result obtained in the replicate determination. Mean. It is the average data which is determined by dividing the sum of set by number of individual and denoted by x bar. You all know x bar equal to summation x over n and the frequency. Median, it is the middle data which is calculated by arranging the raw data in ascending or descending order. If n the number of the varies in data, median n plus 1 variate when n is the odd, median half n over 2 tooth variate plus n over 1 plus 1 variate when n is the even number. Range. It is the difference between the highest and lowest result, which is denoted by R equal to highest minus lowest. Average deviation, mean deviation, it is one of the method of showing dispersion or way of the ascertaining the deviation from the central value. The average or mean deviation of a single measurement is the mean of the deviation of all individual measurements. It is calculated by determining the mean of the results, calculating the deviation of each individual's measurements from the mean, dividing the sum of the deviations by measurements. So average deviation is the summation x minus x bar over n. X bar means mean or median. Coefficients of various coefficient of mean deviation about the mean deviation about the mean over mean, coefficients of mean deviation about median, mean deviation about median over median, relative average deviation d over x multiply 100. So relative average equal to d over x multiply 1000, ppt part per 1000. Standard deviation, it measures the how closely the data clustered about the mean and also called root mean square deviation. The smaller the standard deviation, data are clustered about the mean, that is the homogeneity observed when standard deviation is small. The standard deviation of infinitely large set of the experimental data is square root of the average of the square of the individual deviation from the mean x bar and denoted by sigma. Sigma equal to root over summation x minus x bar squared over n. In case of n is greater than 30, sigma equal to root over summation x minus x bar squared over n minus 1. Coefficient of variation, the relative measure of dispersion is known as coefficient of variation. Coefficient of variation equal to sigma over x bar multiplied by 100. Variance, the square of the standard deviation is called variance, that is sigma squared. Okay, thanks for watching, and that's now bye bye. See you again.